Hi, this is Conra Holman again. I wanted to now talk about how to transform a parent function from an equation. First of all, I think it's a really good idea for you to make yourself familiar with parent functions, as we sometimes call these. In my transformations folder, in my Google Drive folder, I have made this blank handout for you guys. I think you will learn a lot if you go through and fill out the tables and plot the graphs. But then above and beyond that, I'd like you to think about a few things. I'd like you to think about why did I pick the x values I did? Pick equations that look similar to each other and look at how the graphs are different and how the graphs are the same and figure out why that is happening. Once we know what the parent functions are, then we can look at variations on those and be able to graph them quickly. Okay, so we use this terminology when we are giving you the rules for how to transform functions, and I wanted to help you figure out what we mean by that. So we talk about the numbers being added or multiplied to the function, and we talk about whether the numbers are inside or outside. For example, I see this function and I see this number 2, and I want to look at the relationship between the 2 and the x. So I want to ask, is this thing added or is there a multiplication that's connecting these things? The other aspect that we want to look at is we want to look at whether it's inside or whether it's outside. So the word inside is referring to the fact that you would do that operation before you applied the parent function. So in this case, do you take your x value and multiply it by 2 and then apply the square root? Or do you apply the square root and then multiply it by 2? If you do it before you apply your parent function, then we call it inside. And if you do it after you apply the parent function, we call it outside. The other thing that we worry about is we worry about if we can figure out what the parent function is. So in this case, hopefully you see that the parent function is going to be the function y equals the square root of x. And then the number 2 in this problem has been inserted by multiplication. It's the 2 times the x. And you multiply the x values by 2 before you apply the square root when you follow the order of operations. So in this problem, we would say that the 2 was multiplied inside, not outside. So for this function, the parent function, hopefully it's clear to you that y equals cube root of x would be the parent function. And then that 2 in this problem, is it inserted by multiplication or is it inserted by addition? So I don't want 4 categories, I want 2 categories because that makes it much easier to work with. So you'll notice up here I've commented, and I'm considering subtraction to be addition by an opposite, and I'm considering division to be multiplication by a reciprocal. That way I only have 2 categories to worry about. So while you see a subtraction sign, I'm really going to think of it as addition. And the third question, is it inserted inside or is it inserted outside? So if you were going to plug a number in for x, so when we look at this by the order of operations, the cube root, we can think of it as an exponent, but then radicals have an implied set of parentheses inside them. And so by please excuse my dear Aunt Sally, we'd have to do the parentheses before we did the exponent. So we do the subtraction before we take the cube root. So we say that the 2 is inside the function. So we have addition inside. Okay, so again, what's the parent function? So hopefully you're very familiar with the graph of y equals absolute value of x. Hopefully you could graph it very quickly without having to think much about it. So we have this number 2, and is it connected by addition or is it connected by multiplication? Hopefully it's obvious that there is an implied multiplication sign in there. There's no addition sign in there. And is the 2 inside or outside? So in this case, if I were going to plug in, say, -3 for x, I would take the absolute value of the -3 before I multiplied the answer by 2. So the 2 in this case is outside. It's multiplication and it's outside. Okay, so Again, what's the parent function? So you should know what the graph of y equals x squared looks like. In this case, you would square before you added, and it is addition, it's not multiplication. And so because you do the addition after you square it, the 2 would be outside the function. So we have addition outside in this particular case. Okay, so in my Google Drive folder for my students, you have access to this transforming overview. This is the first page of that document. This is what I'm going to be referring to. I'm going to be taking little pieces of this and showing you how to apply this. But I put everything together in one place so that you could see my memory devices and so that you could compare and contrast that number to the y values. So g of x equals square root of 2x. We already said that 2 was multiplied inside. And so I know it's going to be stretching or shrinking, and it could be a reflection. Because it's inside, it's going to be horizontal. I look at this and I've put my 2 in for my b. The absolute value of 2 is bigger than 1, so it's going to be a shrink. So it's going to be horizontal, shrink. It's positive, so there is no horizontal reflection. And so I can multiply all the x values by 1/2 if I want to. Cube root of x minus 2. So we already noticed negative 2 was added inside. And so addition told me it was shifting. Inside told me it was horizontal, so I know it's a horizontal shift. My h in this case was a positive 2. And so that tells me that I'm going to go right. So I'm going to shift right by 2 units, and I can add that 2 to the x values to get points on the graph. Last graph we had p of x equals x squared plus 2, and we decided that 2 was added outside. So outside addition told us that it was shifting. Outside told us it was vertical. And that 2 is in the k position, and it's positive, so we're going up. So the graph is shifted up 2, and we can get it by adding 2 to the y values. I added 2 more in here, so g of x equals square root of negative 2x. I wanted to have a couple of negative numbers in here. So we still have it's multiplied inside. We still know all of this, positive 2. But notice that in addition to the absolute value of negative 2 being bigger than 1, which tells us there's a shrink, it's also negative, so we know there's going to be a reflection. So we're going to have a horizontal reflection, and we can get that by multiplying the x values by 1 over b, which in this case is 1 over negative 2. Looks like I have a little typo there. In this case, we have multiplication outside. So we remember all these from a minute ago. The absolute value of negative 2 is bigger than 1, so it's a stretch. It's vertical stretch. It's negative, so it's going to be a reflection. And so we're going to have a vertical stretch and a vertical reflection, and we can get points on the graph by taking the old points and multiplying the y values by negative 2. If you wanted to combine the transformations, here is the order of operations. We will do it in the order 1, 2, 3, 4. So left to right inside, and then left to right outside. So the big thing is that you do B before you do H, and you do A before you do K. So here's a list of all those put together. I hope this helps. Enjoy doing your homework.